All right, let's get right into it. Today, we're digging into a cosmic mystery that's happening right now, in real time. We've got a visitor, an object from another star system, and it's moving through our solar system in a way that, frankly, has scientists scratching their heads.
So here's the deal. This interstellar visitor, its official name is 3I/Atlas, it's speeding up when it shouldn't be. And this one little fact has kicked up a massive storm, with everyone from top astronomers to people all over social media throwing out theories. So what on earth is going on?
To figure this out, we're going to treat this like a cosmic detective story. First, we'll look at the mystery itself. Then, we'll check out a very similar unsolved case that set the stage for all this. After that, we'll dive into the latest clues, identify the two main suspects, and then see how this whole thing just exploded into a media and political circus. And finally, we'll pull a really important lesson from the history of science.
Okay, so let's open up the case file on our mystery object. From the second astronomers laid eyes on it, they knew 3I/Atlas was different. This wasn't your average space rock. It was a genuine cosmic anomaly.
I mean, think about it. It's only the third object we've ever spotted coming from another star system. It's ancient, older than our own sun. It's moving at this incredible speed, and its chemical makeup is just weird. It's got a strange carbon dioxide signature, an unusual ratio of nickel to iron, and the way it reflects light, and even the tail it has. All of these things were immediate red flags for scientists.
But you know, this kind of weird behavior isn't totally unprecedented. To really get what's going on with Atlas, we have to jump in a time machine back to 2017 and take a look at the very first interstellar visitor we ever spotted, a mysterious object named Oumuamua. So back in 2017, Oumuamua completely baffled everyone. As it was leaving our solar system, it hit the gas. It accelerated, but there was no comet tail, no plume of gas to explain the push. This prompted the Harvard astronomer Avi Loeb to float a really wild idea. What if it wasn't a rock at all? What if it was something artificial, like a super thin solar sail? Now, he got a ton of flack for that, but the mystery was never actually solved. And that set a very controversial stage for the arrival of our new visitor.
Okay, now let's get to the new evidence. Because as 3I/Atlas made its big turn around the sun, its behavior went from just strange to completely bizarre. And that's when this scientific puzzle really blew up into a global phenomenon. Observers started cataloging a whole new list of weirdness. First, it suddenly flared up, getting 5 times brighter for no clear reason. Then it started changing color, shifting from a normal reddish color to green and then to a totally unexpected blue. But the third observation, well, that's the real smoking gun. That's right, just like Oumuamua, 3I/Atlas sped up for reasons that gravity alone can't explain. And let's be super clear, this isn't just a theory or speculation, this is confirmed data coming straight out of NASA's own Jet Propulsion Laboratory. It happened. And here's the hard data itself. Now, you don't need to be a rocket scientist to get the main point here. Just look at the middle column. That's the mysterious push it's getting. Now compare those numbers to the last column, which is the margin of error. The push is way, way bigger than any potential error. The bottom line, this acceleration is not a mistake. It's real.
So what could possibly be causing this? Our investigation now zooms in on 2 prime suspects. We've got a perfectly natural explanation and, well, we've got a much more extraordinary one.
The leading natural explanation is all about a basic rule of physics we see every single day, governing everything from the way we walk to how rockets blast off into space. And this explains it perfectly. When a comet gets close to the sun, the ice on it heats up and blasts off as gas and dust. That blast of gas shooting out is the action, and the reaction is a push in the opposite direction, nudging the comet forward. It's basically acting like a tiny natural rocket. We call it outgassing. So here is the absolute crucial point. The natural explanation, the comet theory, says this outgassing should be kicking off a huge amount of material, and that should create a massive, super obvious tail of gas and dust. The alternative theory, that it's artificial, doesn't need a tail at all. So the key piece of evidence in this whole whodunit is the tail, or maybe the lack of one. And according to Avi Loeb's math, it's not a small amount of material we're talking about. For outgassing to cause the speed boost we saw, Atlas would have had to blast off roughly 15% of its entire mass as it went around the sun. An event that violent should have been unmistakable, a spectacular, massive cloud of debris.
But this story isn't just about science and telescopes anymore. Oh no, the debate has completely escaped the lab and exploded into the public arena, turning into a political and media firestorm that has made the actual investigation really, really complicated.
Things took a wild turn when a U.S. Congresswoman, Anna Paulina Luna, started publicly pushing NASA to release its best pictures of the object, high-resolution images that were taken by a Mars orbiter when Atlas was much closer. She then tweeted that NASA agreed, and then she added this very cryptic line, "Avi Loeb is correct about the tail." To this day, nobody is quite sure what she meant by that.
And just to add another layer of drama to the whole thing, the head of NASA was dismissed right around the same time. Now, this could be a total coincidence, of course, but the timing, combined with the fact that the agency is staying totally silent on its best photos, well, it just poured gasoline on the fire of public speculation.
The whole situation hit peak absurdity when celebrities like Kim Kardashian started asking about it on social media. She actually got direct replies from NASA officials, and it prompted Avi Loeb himself to call for her to get involved. And just like that, this wasn't an astronomy debate anymore. It was a full-blown cultural moment.
So you might be wondering, why is there so much intense, almost angry resistance to even thinking about Loeb's ideas? Well, to understand the passion here, we really need to look back at history. Because science has this long and often pretty brutal track record of crushing radical new ideas that challenge what everybody thinks they know.
Just look at the tragic story of Ignaz Semmelweis. In the 1840s, this doctor proved with undeniable data that doctors were killing new mothers because they weren't washing their hands. He showed that a simple chlorine wash stopped the deaths. And what happened? The entire medical establishment laughed at him. They called his idea of invisible germs extravagant and ridiculous. They destroyed his career. He ended up dying alone in a psychiatric hospital. And of course, decades later, his crazy idea became the absolute foundation of all modern medicine.
And Semmelweis wasn't some one-off case. Galileo, Darwin, the guy who came up with continental drift, the priest who proposed the Big Bang, so many of science's biggest heroes were first treated like absolute heretics. Their only crime was showing evidence that went against what all the smart people knew was true.
And that history teaches us a really important lesson. It's always easy to laugh at a weird new idea, but the real spirit of science, the whole point of it, is to follow the evidence no matter where it leads. On December 19th, 3I/Atlas is going to make its closest flyby of Earth, and that's our best and maybe our last chance to get the data we need to finally solve this thing once and for all.
So in the end, whether 3I Atlas is just a really, really weird comet or something else entirely, its journey through our little corner of the cosmos is forcing us to ask some big questions, not just about what's out there in the dark, but about how we search for answers and what we're willing to consider when the universe shows us something we truly don't understand.